Today you're going to be doing a worksheet about rational or irrational numbers, and I just wanted to make sure that you kind of understand them. I hope you watched the 2 YouTube videos that I had to kind of get you in the mode for learning them. There are 3 types of rational numbers, so let's look at the first type. It's a terminating or non-terminating decimal. So if the decimal terminates, ends, the number is a rational number. So here are some examples of terminating decimals, like 1.5, 21.444, and it's done. And then here is another one right here. So these are examples of terminating decimals. But if you have a decimal that doesn't terminate, and you kind of see like a 1.23, and then you see these 3 dots, or you start to see this pattern and ... or if you see 2.77 or something with a bar over it, that indicates that those will go on forever and ever and ever, and you won't know what it is. So another irrational number is pi. We know, you guys all know it as 3.14, but there are a whole bunch of decimals, and there are computers who are designated to figuring out the value of pi. The second type of rational numbers are decimals with patterns that repeat or versus growing. So if the decimal has a repeating pattern, the number is rational. So here's an example. If I have 1.3 bar, I know that it's going to continue on and on and on as 3.33, 1.33. So this one's a rational number. If you look at this pattern, that pattern's going to repeat, so it's going to be rational. Even this one right here, this long pattern, you see where I have the 0.52156, and then it repeats again. That is considered a rational number. Now, if the decimal has growing patterns, the number is irrational. So if you look at this, and I have this 2, 1, and then I have 2 with 2 1 ones, and then I have this is irrational, because even though it seems like you know what the next pattern is going to be, it's just not a number that has a set pattern. Here's another example of this here. Look at it very closely. You start to see this repeating pattern go on and on and on, but here this one has 3 4s and this one has 2 4s, and so if you look at the next pattern, you're thinking, okay, there's going to be 4 4s. It sounds rational, but it's not. It's irrational. Now, what is neat is we've been dealing with the type 3 of numbers, and so those are square roots. And what we always should do is simplify the square roots to determine if it is a rational or irrational number. So here's some examples. You guys all know by now the square root of 25 is equal to 5. That is definitely a rational number because you know how it ends. Then if you look at the square root of 400, you know it's equal to 20. That is definitely a rational number. You know how it ends. It makes sense. But a lot of the square roots that aren't perfect square roots, which you've been estimating so well, and I'm so proud of you guys for doing it, are irrational numbers because, for example, square root of 5, which I know a lot of you can kind of guess, is about 2.2. When you actually plug that into the calculator, you get this number that goes on and on and on and on and on, and it is just not a rational numbers. Square root of 12 is another one of those irrational numbers. So there's those rational and irrational numbers, and when I come back on Thursday, I'm going to see if you can actually identify what they are. What I'd like you to do with your partner is to take this page and come up with examples of terminating decimals using a calculator or coming up with them in your head, examples of non-terminating decimals. And please don't use the ones that were given to you. Here's the second one. You're going to look at type 2, and you're going to also work with your partner to make sure that you can come up with different examples. So go ahead and work with your partner on that, and if you can just stop this for a moment. On Thursday, I'll have you guys share out some of these results. Everyone, I want you to look at this page, and what you're going to do is you're going to categorize these different numbers as rational or irrational, and they're either one or the other. What I would do also is take these fractions in order to figure out if they're rational or irrational and divide them to see what ends up happening on your calculator. Now, when you're done, you're going to check the answer key, and that's located at the bottom of this worksheet. Well, take a look at the answer key right here, and you're going to notice that your fractions are actually rational numbers. So our 7/3 and our negative 24 over 4, and even our 2/7. Again, when you divided them, you'd see this repeating number. They are considered rational numbers if they are in fraction form. Again, we will do some more work on rational and irrational numbers on Thursday when I get back. I hope that you will take the time to look at your Pythagorean theorem slides and review for them. What I'd like you to do right now is to take a piece of paper out and write down what your understanding of rational and irrational numbers are so that you can make a statement about it on Thursday. So again, what do you know is a rational number and an irrational number? Have a good day. I will see you on Thursday.